The two particles will take it. So the velocity of particle A, VA, and this is VB. So both are having, both are moving on same circle. So we are going to discuss now the relative motion between them. So let the angular velocity of this will be, so they'll have a different speed, VA, this will be. So I want angular velocity of A with respect to B. Both are in same sense. Both particles, first case I'm starting. Particles A and B are moving in same sense. Okay, this one. So there's one basic condition with a different angular velocity. Particles A and B are moving in same sense with different. Okay, there's a first case I'm assuming. This one. Now, because of different angular velocity, so definitely how you show omega A should be like this, no? Am I right? Here only I'll show it, so it'll be easy for you. And this will be, this is VA, this is VB. This is omega B, this is omega A. Okay, fine, all of you. Let they move in a circular path of radius r. At somewhere, I'll take a position like this. Let this be theta. Let's go back to the basic definition. Just now we brought it, no? The angular velocity of A with respect to B. So that particular basic formula is what I'm going to apply it here. Now, this is R. So how much this distance will be? R sine theta. This distance should be R sine theta. This distance should be R sine theta. What is the velocity of particles perpendicular to line joining them? So in this direction, if this is theta, this should be theta. Will I agree this? So, and if this is theta, this will be theta, no? 90 minus theta, theta. Okay, this will be theta. Okay, look at the angles here now. So what is the angular velocity of A with respect to B, or angular velocity with respect to B with respect? I think both are same. Just now we have concluded here. So from that, so what is the equation you can write it now? Angular velocity of A with respect to B, or B with respect to A, you calculate. What is the formula now? Velocity of B with respect to A. VBA by the perpendicular distance along line joining the A and B. BA, I'll write it. So what is VB minus VA? Velocity VB sine theta. Minus of minus VA sine theta. Why negative sign? Because if I take VB sine theta positive, VB sine theta positive, then VA sine theta should be negative. No? Then what is the length BA equal to 2R sine theta? Okay, this you keep it. Now VB plus VA by 2R. What is VB equal to? VB equal to? So looking at the diagram here, VB should be equal to R omega B. So we know, so some here only will write it before this. VA equal to R omega A. VB equal to R omega B. So in place of VB, what you can write? R omega B. In place of VA, R omega A by 2. So if they are in same sense, what is the angular velocity? Will get added up. Anybody direction of this? The direction of omega B and omega A also. So there should be, so omega BA in what direction it should be? It should be anti-clockwise. So omega B, what is the sense of omega B? I'll show all the things here anti-clockwise. Omega A anti-clockwise. What about omega BA? It's also anti-clockwise. Where omega B will be at the axis, you are going to show it here out of the plane. Agreed, am I right? The omega B here. Similarly, omega out of the plane. What about omega B? You should not show it here. You have to show it here. It will be out of the plane here. Angular velocity of B with respect. What about angular velocity of A with respect to B? It will also the same vector. It will be here. Angular velocity of A with respect to B. Both will be in same direction. Out of the plane. So means I want omega angular velocity of A with respect to B. That also will be out of the plane. But the vector where it is acting, it will act at A. So omega BA, it will act at A. It will be out of the plane here. What about here? Omega AB, it will be out of the plane, will pass through point B. Able to get this one? So what is the basic definition? Angular velocity of B with respect to A. What is the basic definition? Relative velocity, this one, relative velocity perpendicular to line joining the particles A and B by the perpendicular or the separation between the particles A and B. So how we should measure? The velocity, the relative velocity should be measured perpendicular to line joining AB. Those quantities should be substituted, not the components which are along AB. Which component of velocities you should substitute? Those velocities which are directed perpendicular to line joining AB should be substituted here. Are you getting no? VB sine theta, VB cos theta. So here VB cos to VB sine theta. Which component is should be substituted here? VB sine theta. Sir, why? Any reason? Because we know how V and R will be related. V should be perpendicular to R. So therefore, component of velocities of particle directed perpendicular to line joining AB should be substituted here. There's a basic definition. Similarly, if they move in opposite sense, the same problem. Let me show parallelly both. It'll be easy for you. See, we are not supposed to remember formula. First, we should analyze it. Oh, how it will come. Then what happens? Based on this, the application problems will come. Now they are moving in opposite sense, the particle. This will be VB. This will be VA. So this is again R. These are how omega B will be how omega A like this. What about omega B? So let this be theta. First, okay, look at the arrow for angular velocities. They're in opposite sense, no? Now what will be the angular velocity of A with respect to B or angular velocity of B with respect to A? So again, as usual, this will be R sine theta. There's a particle B, there's a particle A. Particles are moving in opposite sense. Find anything. Find omega AB or omega BA. What is the basic formula now? Find omega BA. Line joining AB, they should be equal to how much? AB equal to 2R sin theta, like earlier what we did, BA that one. So here omega BA is equal to which velocities now you are going to. So this is theta. So this should be theta, no? And this is theta. This is theta. And now this will be VBA by distance BA. So VB now VB sine theta. Not like minus of minus. It will be just two R sine theta. So this will be VB minus VA by 2R. What is VB equal to? R omega B. Okay, like this. Now we are getting what is the sense? Who will give the sense? If omega b greater than omega a, the resultant will be in the direction of omega b. If omega a greater than omega b, the resultant will be omega b will be opposite to omega, that one. So which will be greater along that direction? It will be there. So look at the omega b and omega. The velocity, the vectors will be directed opposite, and it will be along the direction of the greater one. So particles, two particles moving on same circular path, same circle, or the angular velocity of one with respect to the other. This is the formula. It depends upon the position. I just took a case like this. So anyway, arbitrary way. So try to get the distance between them using the concept of circle. Then resolve the velocities perpendicular to line joining the particles, component of velocity. Those components which are perpendicular to line joining them will determine the angular velocity.
Sir,
Uh,
sir, but if you look at B from A, then it is not necessary that it will move in a circular path, right, sir?
The frame of reference will be different. No, I'm just calculating angular velocity here. Oh, no. They are moving in circular path. Particles in B are moving in same sense with a different angular velocity in a circle, on a circle.
Sir, if you look at B from A, then it is not necessary that B will move in a circular path, right, sir?
Need not. I'm not saying anything. In that position, no. In that position only, no. It is.
Okay, sir, at that instant.
At that instant, it is.
Okay, sir.
The direction of omega BA depends upon which is greater. If omega B greater than A, omega BA will be in the direction of omega B. If omega A greater than omega B, the direction of omega BA will be in the direction of omega A. The greater one will determine the sign. Okay, fine. So let's go for the numericals. See the same thing. How numericals will come.